video part 3. We're using those same formulas as the last two videos. What we want to do is find the exact value of the trig functions, and what we're given is the sine of u is 5/13, and the cosine of v, a different angle, is -3/5. And these angles fall in the second quadrant. And what we want to find is the sine of u plus v, the cosine of u minus v, and the tangent of u minus v. So the first thing we want to do is draw right triangles. So let's start with the sine of u over v. Sine of u, which equals 5/13. If you remember right triangle trig, the sine of an angle is found by taking the opposite over the hypotenuse. So here is my angle, here is my opposite, here is my hypotenuse. So I have 5 and 13. There's one missing x that I don't know, which is called the side adjacent. So we're going to look for that in a little bit. Now let's come over to the other angle. The cosine of v equals -3/5. We're going to again draw that triangle. Cosine of v is for a right triangle trig, adjacent over the hypotenuse. So my adjacent is -3. My hypotenuse is 5. And then I have this side opposite, which I'll call y, is unknown. So to find the other trig functions in these angles, I want to find that missing third side. So we're going to use the Pythagorean Theorem. A squared plus b squared equals c squared. So let's find the red x. So we're going to take y. Here's my y. Here's my r. And then here's my x. I want to find x. So I'm going to take x squared plus y squared equals r squared. X squared plus 25 equals 169. Subtract 25 from both sides. X squared equals 144. X equals plus or minus the square root of 144, which is plus or minus 12. Now, depending on our quadrant is if our x is going to be a positive or negative. So let's head up to this second quadrant. That x has to be a negative because we're in the second quadrant. So I'm going to go x equals -12. And there's our side adjacent. Now let's head over to the second angle, the v angle. We want to find y. So here's our x, here's our y, here's our r. We're going to use Pythagorean Theorem again and find the y. So we have x squared plus y squared equals r squared. We'll solve for y. So -3 times -3 is 9. Y squared and then 25. Subtract 9 from both sides. And we get y squared equals 16. Square root 16 gives you plus or minus 4. Now let's look at the quadrant. For quadrant 2, our y has to be a positive. So we have a positive 4. All right. What is the cosine of u? So remember, cosine of the angle represents adjacent which is your x, over your hypotenuse, adjacent over hypotenuse, or x over r. So we have -12 over 13. The tangent, right triangle trig, is opposite, which is y, over adjacent, x. So we have 5 over -12. Let's head over to the sine of the angle in the blue. The sine is y over r. So y is 4 and r is 5. And then the sine or tangent of v is y over x. Y is 4 and x is -3. What we've done is we found the sine, cosine, and tangent of those angles. We're going to now find the sine of u plus v. So we have to choose the appropriate formula. So in this case, it's a plus b. So we're going to take right here the sine of u cosine of v plus the cosine of u times the sine of v. So I'm just going to rewrite this sine down here so I can see it. The sine of u was given to us as 5/13. And the cosine of v was given to us as -3/5. All right. So now let's go ahead and substitute in the things that we need. So the sine of u is our first thing we need. So that's 5/13. I just circled it. The cosine of v is -3/5. Just circled that. Plus the cosine of u, -12/13. And the sine of v, 4/5. And what we do is we just multiply across. 5 times -3 is -15. And then 13 times 5 is 65. Minus -12 times 4 is -48 over to 65. And then combine the fractions together. So -15 minus 48 over 65. And then combine your numerator. -15 minus 48 is -63. So that is the sine of u plus v. What we can do is we can continue this problem by taking the cosine of u minus v, which would be this formula, and then substituting in the cosine of u, cosine of v, plus the sine of u, sine of v, and then substitute those fractions in. And then for this last one, the tangent of u minus v, we'd use this formula. And then substitute those fractions in. So the tangent of u minus the tangent of v, all over 1 plus the tangent of u, tangent of v. And again, we found all of these pieces up in here.